The secondary motion tool is my favorite all of the auto physics tools. I mean, just look at it. How cool is this? It lets you control overlapping action and follow through, making your animations more dynamic. Now, the only issue I run into is that I often find myself tweaking the sliders without really knowing how they will influence the animation. And that's exactly why I'm making this video, for myself as much as for you, so we can quickly refer back to it anytime. I will use this simple pendulum rig so we can focus on how each setting affects the secondary motion. In the animation there will be a cycling back and forth motion, then it will come to a stop with a slight overshoot, and I've also added enough frames at the end so Cascadeur can add some follow through. And since secondary motion affects the rigid bodies of your rig, you need to select either the auto posing controllers or in this case the point controllers. I will select all points in the dangly part of the rig, and on the timeline I will make sure to select the whole interval. Generally you want to apply these settings to the entire animation or certain parts of the animation, not just to individual keyframes. And to apply these settings for the selected interval, activate this button so you get this red border. Now if we go to the object properties, we can see the settings for the secondary motion. First we have local blending and global blending. These control how much the bones are pulled back to their original position, allowing you to adjust how rigid or flexible that body part is. Local blending affects how much the bones stays within its local space. This refers to the internal motion, like if a tail segment tries to return to its original angle. The higher the value, the more the bone resists excessive motion. So if you want more blending, you should set this value to a lower number. Global blending, on the other hand, works in global space, controlling how much the object stays oriented in the scene. Increasing this will pull the entire chain back to its original global rotation, creating kind of like an inverse effect of the local blending. I guess this can be useful if you want to stabilize the end of the bone chain, but in most cases it can be kept at 0. Next is damping, which controls how quickly the motion fades out. A lower damping value lets the pendulum swing back and forth, creating more follow through and overshoot, while a higher value will stop the motion more quickly. And this is essential for controlling how fluid or snappy your animation looks. As the pendulum comes to a sudden stop, higher damping value reduces unwanted wiggle, but keep in mind that this will also limit the strength of local blending. The last settings here is the air friction, which acts like wind resistance. With air friction at 0, the bones can swing freely, but increasing it will slow them down, and this introduces more drag to the animation, delaying the movement of the end of the chain compared to the base. If you increase this value a lot, the animation will look almost like it's underwater, which will also affect how much follow through you get. I found that the best looking result is to use higher air friction values when the animation is fast, but as the action comes to a stop, reduce air friction and you will get a more pleasant follow through. And if there is too much wiggle at this point, increase the damping only towards the end of the interval. And there is one more setting that works globally, not on the point controller levels as we've seen this far. You can find it under the physics tab if you scroll down, and here you can choose whether gravity should affect secondary motion or not. In this case it has a similar effect to damping. For passive objects like here the pendulum, I would turn it on because it gives a more natural result. And if it's turned on, the strength of gravity and the mass of the rigid bodies will influence how strong the effect is. So the next time you are working on your animation, remember, use local blending to convey rigidity, damping for follow through, and air friction to introduce drag to it. I encourage you to experiment with them in your own animation, and I hope this video can help you achieve the results you are looking for.